Hey, how's it going, Math 1 kids? Mr. Zamudio here again. Lesson 1.3, and today we're going to be talking about functions and non-functions. I know it says activity 3.1 here, but this is lesson 1.3, so you can just ignore this little 3.1 if that confuses you. A mathematical function follows the principle that you may have learned this definition before. Definitely in 8th grade at some point it's taught, so if you remember it, awesome. If you don't remember it, not the end of the world. That's what we're doing these videos for. Hopefully we can help you remember some of that stuff. So a mathematical function is follows the principle that every input has exactly one output. Every input has exactly one output. And I'm going to write the same thing a little differently, and maybe this helps make a little more sense. Every x, so like every x coordinate, has only one y. So every x has only one y. I like to use a simile when talking about functions. So I think functions are kind of like cell phone numbers, I guess. And let's say I have a cell phone number. I'm not actually going to put that on here, but let's say my cell phone number was 1, 2, 3, 4, 5, 6, 7. You guys know that if you were to call that phone number, and that's my cell phone number, that should only go to me, right? It should be my cell phone, so I should be the one that answers it. But if all of a sudden you call that phone number and that same phone number goes to some dude in Sweden, say some dude, that cell phone is not working correctly, right? That cell phone number isn't working correctly. So with functions, think of it as the same thing. In order for a function to work correctly, every input has to go to exactly one output. For every x has to go to exactly one y. So with these cell phones, you understand that one phone number should only go to one person, right? So this, where I just had this dude, this is definitely not okay. Oops, let me do that in red so we can see it a little better. This is not okay. This is not a function, because this input has two outputs, and that shouldn't happen. Every input should have exactly one output. So let me give you an example that is a function. Well, let's say my best friend, who's my best friend? We'll say Mr. K for this video. Let's say Mr. K has this phone number. You call that phone number, goes to Mr. K. And then here's my old phone number. You call that, goes to me. Is this a function? Yeah. And it's a function because each of these inputs, each of these phone numbers, goes to exactly one output. Now, I'm going to throw in a special little case here, and let's see if we can figure this out. So, because I'm a very busy man, and I have a lot of contacts, I actually have two cell phones. So, I have a second cell phone, where that phone number is 555-5555. And if you call that, it also goes to me, because I have two cell phones. Is this scenario right here still a function? Does every input have exactly one output? And the answer to this is yes. This is still a function. This input, the 2, 3, 4, goes to Mr. K. It has exactly one output. This input, 1, 2, 3, 4, 5, 6, 7, goes exactly to one person, and it goes to me. And this phone number also only goes to one person. So this is still a function, right? I can have 2 cell phones. That's fine. But one cell phone number over here can't go to 2 different people. So I think that that's a pretty nice example to explain functions and non-functions. If that didn't make sense, I'm sorry, guys. But in the past, I know that's helped students before. All right, so we have some examples here of some functions or non-functions. So let's just talk about each of these real quick. So looking at this example, this is called a mapping. We have domain, range. These are kind of interchangeable for x and y's, or inputs and outputs. So let's recognize, is this right here a function? And remember, in order to be a function, each input has to have exactly one output. Well, 1 goes to 2. That's good. The input 4 goes to 5 and -5. So this input has 2 different outputs. So right away, I see that this is not a function. And it's not a function because that 4 has 2 different outputs, right? So remember with that cell phone, if I called the number 4, it goes to 2 different people. That's not good. All right. Over here, this is a nice equation that's in slope-intercept form. You may have learned this. You should have learned this in 8th grade. This is y equals mx plus b. This would make a line that looks something like this. And linear functions are functions. So whenever you see an equation that's in y equals mx plus b form, this is a function. And we'll talk a lot about linear functions later in the year. But for now, anytime you see a y equals mx plus b equation, recognize that that is a function. Now, we can also see these sort of relationships in tables. Now, sometimes this may be a little harder to tell. So recognize at the top these words, domain and range. Remember, that just means x, all the x's, and then all the y's, or all the inputs and all the outputs. So we have to figure out, does every one input go to exactly one output? Well, -1 goes to 1, 2 goes to 0, 5 goes to -5, 6 goes to -5, 7 goes to -8. So where there might be some confusion would be this part right here, where we see that 2 different inputs went to the same output. But that's okay. Remember this as like every input has to go to exactly one output. So 5 went to -5. 6 also went to -5, but that's okay, because each input here still has exactly one output. So this actually is a function. Now graphs. Graphs are a little easier to tell if it is a function, because we have something called the vertical line test. So I'm actually going to come back to this graph in a second and explain what the vertical line test is. Basically, the vertical line test tells you, is it a function or not? So this black piece, this is the graph that was given. And basically, if I drew a vertical line anywhere on the graph, so vertical means up and down, if it is a function, it should only touch your graph one time. So notice I put all these vertical lines, and each time I put one, how many times is it touching the graph? It only touches it once. And what that means is that each input has exactly one output. So this right here is a function. However, if I look at this one over here, notice if I put a line going up and down, a vertical line, it touches twice. So this input, this line going up and down, has two outputs. So that's not a function. This is not good. So looking at this graph, is this a function? Well, let me just put a vertical line anywhere randomly. Going up and down. How many times did that hit the graph? It only hit it one time. And you can see if I put that line anywhere on the graph, it's only going to hit it one time. So each input has exactly one output. So this is also a function. All right, that's it for today, guys. Make sure you have taken some sort of notes, and make sure you answer the questions at the end of this video. That will help me figure out how much of this lesson you guys understood.